Hello my dear friend, I am Soham Jagad. Welcome you all in this science lesson. We are in chapter number 9, that is force and laws of motion. Till now we have seen first law, second law, third law, inertia, momentum, and in the last lecture we have seen conservation of momentum. So let's dig deeper into this topic. So we know that what is, by second law, what is force? Force is rate of change of momentum. Now I can write F is proportional to rate of change of momentum. So I can write delta P divide T. Now you may get question that, sir, what is this triangle P? So I like to say that this triangle like symbol read as delta. It is Greek letter delta, and this delta suggests difference in any quantity. Difference in any quantity. Let's say I say delta T, which means change in temperature. If I say delta M, which means change in mass. So here delta P suggests change in momentum. So F is directly proportional to delta P divide T, that is change in momentum divide time, that is rate of change of momentum. So from second law we have formula F is equal to ma. That is very important and basic formula for second law. And what this formula gave us? This formula gave us quantity of force applied on object. This formula gave us quantity of force applied on object. After that we have law of conservation, that is conservation of momentum. In conservation of momentum, we took one example. I said we have two balls, that is ball A and ball B. This two ball has mass m1, A ball has mass ma, and B ball has mass mb, and it has initial velocity as ua, it has initial velocity as ub. Suppose these both balls are moving in this direction, and I consider UA is greater than UB. UA is greater than UB, which means this ball A is traveling faster with more speed than ball B. And now you know that what will happen when this object move faster than this object. This object goes slowly, but this go with higher speed, and what happened? It will collide. So at some point of time these two balls will collide to each other. Let's say this collision time is t. this collision time is T. This is ball A, this is ball B. This is when collision happened. After that, this ball move something like this. This is our ball A and this is ball B. Now this ball have not same velocity before, but it has velocity VA and VB, which means there is change in velocity after collision. It is obvious that when we have seen accident, in accident there is bike or say car, when they collide, will you think after collision they move with same velocity or say speed? No, their speed will be changed. So here speed of ball A and B will change, and we denote this new speed with VA and VB, and this is our initial speed and this is final speed or say velocity. So by law of conservation, what is conservation? What is to conserve? To conserved, I can say that to conserved is something like to save. To save, which means momentum before collision is equal to total momentum after collision. This two ball has some momentum before collision. What is momentum? Momentum P is equal to M into V. So momentum of this plus momentum of this, I get some value, that is before collision, and after collision I have some value of momentum here plus momentum of this ball B. So total I have some value. So the conservation of momentum says that this both value will be equal. This total momenta will be equal. Total momenta before collision and total momenta after collision. I have to say that, let's say it has value 50. It has value 50, that is distributed like 30 and 20. So this 50 will not change and this 50 remains 50 after collision also. But it may get converted to 25 or 10 40 or 20 30 or any two number, their sum will be 50. So I hope now you understood what is conservation of momentum. This all conservation law, say conservation of momentum, conservation of charge, these are basic law of physics, and these conservation laws are very important. Now another thing, what will happen at this time when collision happened? This ball A exert force on B, and at same time this ball B exert force on A. So we have two force, and I give name as FAB, that is force exerted by A on B, and same force exerted by FBA, that is force exerted by B on A. Why this force are same? Because we have learnt third law now. And what third law said? Third law said for every action there is reaction, and this reactive force is equal in magnitude and opposite in direction. So here I have force that is same, FAB, which means magnitude of force is same, means FAB will equal to FBA, but direction will be opposite. If this AB is in right side direction, this BA will be in left side direction, or if AB in left, this BA will be in right side. What is action and reaction force? I would like to say we can call any force as action force, and at that time we have to take another force as reactive force, or say reaction force. If I say FAB is action force, I have to say FBA as reaction force. If I say FBA is action force, so I have to say FAB is reaction force. So I hope now you understood that I can say action and reaction to any of these force. Not only in this case, but in any case I can say action and reaction to any force. So we have derivation of conservation of momentum. We start our derivation with this step, that is FAB is equal to FBA, but direction of force is different here, so I put negative sign here. Magnitude is equal but direction is different, so I put negative sign here. You can put negative sign here also. So what is FAB? FAB is force exerted by A on B, and FBA is force exerted by B on A. Now by second law we know that F is equal to MA, father is equal to mother. So I write here MA AA is equal to minus MB AB. That is mass of A, acceleration of A, mass of B, acceleration of B. Mass of A will remain same. What is acceleration? Acceleration is rate of change of velocity, and I can write A is equal to delta V divide T. I hope now you remember what is delta V. Delta V is change in velocity, that we can write as V minus U divide T. What is change in velocity? Change in velocity is final minus initial divide T. So I can write here VA minus UA divide T is equal to minus MB VB minus UB divide T. So I hope you can understand. If I cut this T and write MA into VA minus MA into UA is equal to minus MB into VB, this minus minus, plus MB UV. Now what I will do, I will take initial momentum in left side and final momentum in right side. So I can write here MA VA. This minus will be plus if I put in left side. So MB VB is equal to this MB UB, take as it is, and this minus will get plus MA UA. Now I will change side. This right side I shift to left side, and this left side I will write in right side. So I will have MA UA plus MB UB is equal to, I will write this here, MA VA plus MB VB. So this is our formula for conservation of momentum. What is this left side? This left side is momentum of ball A plus momentum of ball B. That is total momenta before collision, or say total momentum before collision. This is momentum of ball A after collision plus momentum of ball B after, that is momenta after collision. So momenta before collision and momenta after collision will be same. So the conservation of momentum states that momenta before collision and momenta after collision will be same unless exerted by any external unbalanced force. Now I would like to say that what is this any external unbalanced force? This collision is ideal collision. What is ideal collision? Which means we are not considering friction here. We are not considering friction here. Now we know that when ball or anything move in this surface exert frictional force in opposite direction. So I can say that this friction is external unbalanced force. But remember my friend, we are not considering this external force in this derivation. This is ideal collision, which means we are not considering any other force acting on this two ball except this force AB and BA. In a real life situation, we have other force like friction force on these two balls, but for derivation and understanding purpose, we consider this collision as ideal collision. So I hope now you understood how this derivation came from second law and momentum combined, and what is basic concept of conservation of momentum. Now, after seeing law of conservation of momentum, let's take one example on it. That is example number 9.6 in our textbook, page number 124. So I read data first. A bullet of mass 20 gram is horizontally fired with velocity 150 meter per second from pistol of mass 2 kg. what is the recoil velocity of pistol? So we have data given here. This is example number 9.6. We have one pistol that is with mass 2 kg. So I write given data first. MP, that is 2 kg. Mass of pistol is 2 kg. MB, that is 20 gram. Mass of bullet is 20 gram. Velocity of bullet VB is equal to 150 meter per second. And what I have to find? Recoil velocity of gun or say pistol. So VP is equal to question mark. So I hope you remember what is recoil velocity. We have discussed recoil force. When we fired gun, we know that by third law, when bullet is fired, at that time bullet exert force on gun that will be equal in magnitude and opposite in direction. So the force in bullet is in this direction. So force exerted by bullet on gun will be in this direction, which is in opposite direction. So this force of bullet, force exerted by bullet on pistol or say gun, that is called recoil force. And this velocity, there is some velocity, yes, there is some velocity by which this gun move in backward direction. So this velocity is known as recoil velocity. So here we have to find this recoil velocity. Let's say we have pistol like this. So we have pistol like this in initial situation. What is happened in initial situation? We have UB and V, UB and UP is equal to 0 meter per second, which means when bullet is not fired, this velocity of bullet plus gun is 0, which means initial velocity is 0. Now this bullet fired. Now what will happen? Velocity of bullet is in this direction, which means force on bullet in this direction. So the recoil force on pistol will be in opposite direction. So the recoil force in backward direction. So we will use here law of conservation of momentum, that is momentum before is equal to momentum after. Before and after, before fire and after fire. Here we have total momentum, or we can say momenta. Momenta before is equal to momenta after. What is momenta before? That is total momentum of bullet plus pistol. So momentum before fire, that is MP, UP plus mb ub. So we can say that this up and ub is 0, so this is 0, which means momentum before firing is 0. Now what is momentum after firing? That is mp vp plus mb vb. Now put the values here. mp, that is mass of pistol. Mass of pistol is 2 kg into vp. vp I have to find. vp I have to find plus mb. mb is 20 gram, but I have to convert this gram into SI unit, that is kilogram. So I can convert mb is equal to 20 gram divide 1000, that is 1, 2 and 3, that is 0.02 kg. I shift decimal point to 1, 2 and 3 point. So I have 0.02 multiplied VB. What is velocity of bullet? That is 150 meter per second. So I have momentum after firing. So this is 2 Vp plus 150 multiplied 2 divide, I can shift this 1 and 2, so 2 divide 100. So I have 5 3s are 5 2s are, I have 3. So after firing I have total momentum 2 Vp plus 3. By conservation of momentum I have momentum before is equal to momentum after. So here I have momentum before is equal to momentum after. So I can equate this equation 1 and equation number 2. Now I equate equation number 1 and 2. What is equation number 2? That is 2 Vp plus 3 is equal to 0. I have to find Vp. So I can write 2 Vp is equal to minus 3. So I have Vp is equal to minus 3 by 2. So Vp I have minus 1.5 meter per second. Here in this example I would like to say note few things. That is, velocity of bullet is 150 meter per second. That is huge velocity. And see here, velocity of pistol is only 1.5 meter per second. And here sign of this velocity is positive and sign of this velocity is negative. Why this happened? Because it indicates that velocity of bullet and velocity of pistol is in opposite direction. Velocity of pistol and mass of pistol is very high compared to bullet. So velocity of pistol is very low. So I hope from this example you can see that how momentum is conserved. So this is very basic and important concept of physics called conservation of momentum. I would like to say, if you want to pursue your higher study in science, you must go through with very intense study of this basics law. So I hope you understood clearly how law of conservation work and this example of law of conservation of momentum. Thank you.